Okay, absolute value. So we know absolute value is the distance a number is from 0 on the number line. So absolute value of 5 is 5. The absolute value of negative 5 is 5. Now, one of the things we're going to look at also is not just equal to, but greater than and less than. And one of the things they have this helpful hint over here, it says think. Great or inequalities involving greater than or greater than or equal to symbols are what we call disjunctions. That means they go away from each other. Okay? Think less than inequalities involving less than or equal to symbols are conjunctions, which means they come together. So we have or in great or, okay, apart, disjunction, and in less than means come together. Now, when that changes, okay, sometimes it changes, is you have to be careful when your coefficient is negative. Okay, so watch out for that. All right. So when we solve absolute value we've if we have the absolute value of x equals a could be positive or a could be negative, right? So we're going to be solving two equations every time we solve anything here. Okay? If it is an inequality, here it says absolute value of x is less than a. So it says x is either greater than negative a or less than positive a. If it's greater than a, it's either less than negative a or greater than a. And we'll look at these as we do those inequalities. All right. So, solving the absolute value equation, let a, b, and c be constants, and c is greater than 0. And why is it greater than 0? Because absolute values are always positive. Okay? So then, ax plus b must equal positive c, and ax plus b would equal what? Negative c. Because it could be a positive number or it could be a negative number. So we have solely super steps for solving absolute values. First of all, he says here, solve for the absolute value. In other words, we want to do this. The first thing we want to do is we want to isolate the absolute value. What does that mean? Okay. We're going to get it by itself. Yep. Just like we did with the radicals. We want to get it by itself. So we have to think about anything that's inside the absolute value. Think of it as a grouping symbol. Okay, absolute value is a grouping symbol. And anything that's outside of that on the same side of the equal sign or inequality sign, we're going to move to the other side first. Okay. Then we're going to write two equations. All right, so it's either going to be equal to the positive or equal to the negative. All right, so we'll be using these two equations then. Write it as a positive. Oh, not going to work. Yeah. And as a negative. And then we will solve from there. Okay, here we go. Numero uno. (11) R, the absolute value of that equals 77 over 12. So that means then that 11 over 4R equals 77 over 12, or 11 over 4R equals negative 77 over 12. And this might be a day where a separate sheet of paper might be your friend, okay, because you're going to run out of room probably. So we've got to solve both these equations. So when you have an absolute value, you're always going to end up, well, not always, most of the time you're going to end up with two solutions, okay? Because it could be, from the original, could be positive or negative. So here we're going to multiply both sides by 4 over 11. Right? Instead of dividing by 11/4, we multiply by the reciprocal. So R equals, let's see, 77 over 33, right? Okay. Plus or minus 77 over 33. All right? And if they're both the same number, you can just do plus or minus. How often is that going to happen? Not often. Okay? Only when it's just one variable here and there's nothing else inside the absolute value. Okay. All right. So we're going to kind of condense this a little bit today. Okay. Number 2, I'm going to condense it in the fact that we're going to do step 1 only a little bit, okay, not all the times, right? So what's the first thing I wrote up there? What's step number 1? Okay, isolate the absolute value, get it by itself, okay? So here I have absolute value of x plus 2, but I have outside of that 1/3. So the first thing I have to do is get rid of that 1/3. Okay, so to get rid of it, I'm going to do what? Multiply it by 3, both sides, the reciprocal. All right. So our first step is multiply by 3. So we get the absolute value of x plus 2 equals 18. Now I've isolated the absolute value, and we can solve the two equations. X plus 2 equals 18, or x plus 2 equals negative 18. Right. Subtract 2 both sides, and both of them. So we get x equals 16 or negative 20. And we're using the word or here. Why? It can't be 16 and negative 20 at the same time, can it? All right? So we use or. Whenever it's an equal sign, absolute value, what goes between them is or. Okay? Number 3, absolute value of 2x minus 9 equals negative 13. Donovan, what do we do first? Add 9 to both sides. Good. Plus 9. So the absolute value of 2x equals negative 4. When does that happen? Absolute value can never equal a negative number. So, what is the answer to number 3? No solution. Don't do the work. Okay? No solution. Okay? You do. Okay. Inequalities. What's different when we have an inequality instead of an equation? Nothing except, okay? There's only one thing different, and that's when we go to the negative, okay? We switch the direction of the inequality sign. All right, so here we've got 6 times the absolute value of 5 plus 5r, less than 30. Step number 1 is isolate the absolute value. So the first thing I need to do is divide by 6. Okay. Now, okay, I've isolated the absolute value. Now I've got to pull it apart into 2 inequalities. Okay. The first inequality is exactly as written without the absolute value sign. The second inequality, we are going to change the direction of the inequality sign to go with a negative. Okay? So when you write the negative, you have to change the direction of the inequality sign. Because why? Well, if we multiply or divide by a negative number, we have to switch the direction of the inequality symbol. Right? So everything else applies. Now, the only thing different here is am I going to have a conjunction? All right? In other words, have r in the middle and less than and greater than. Or am I going to have a disjunction? Okay? And the whole thing applies from what does this inequality sign say? It says what? Less than. Okay? All right, less than. So that means that these are, if I graph my answers when I'm done on a number line, they would come together. All right? So solve. Subtract 5. 5r is less than, 0. Hey, that's nice. That's a good one. Oops. So we divide by 5. R is less than 0. Okay, cool. Subtract 5 over here. 5r is greater than negative 10. Divide by 5. R is greater than negative 2. So I have to write this as a compound inequality and say that r is greater than negative 2, less than 0. So your final answer has to look like either this, or there has to be an or between them, okay? Because it would be great or in that case, all right? This is a less than, all right? Come on. All right? So when you're done, you have to write it as a compound inequality like this. All right? Because it is less than. Okay, number 7. Number 7 says great or and equal to. So that means that when I'm done, I'm going to have A is greater than this number or A is less than this number. Okay? So, first thing, we're going to isolate the absolute value. So we've got to move the 1. Subtract 1 from both sides. Oh, make sure that 21 is positive on yours. Okay, I changed that 21 to positive. Okay, it changes the whole perspective because if the 21 was negative, there's no solution, which Justice wrote down. Good job, Justice. Okay, all right. Because I took away the equal sign, I needed to make that positive. Sorry, Justice. So absolute value of negative 8 plus 2a is greater than or equal to 20. So, negative 8 plus 2a is greater than or equal to 20. Or, negative 8 plus 2a is less than or equal to negative 20. I gotta move this. So we add 8 to both sides in both of them. So when you're done, we have A is greater than or equal to 14, or A is less than or equal to negative 6. Right, when I divide by 2? Greater than or equal to 14, less than or equal to negative 6. All right, so I want you to do number 8. Do number 8. Okay, might save those for the quiz tomorrow. Yes, I did say quiz tomorrow. Okay, all right, last question. Michael Jordan. How many of you know who Michael Jordan is? Okay, Michael Jordan averaged 37 points per game in 1987. Suppose in one game MJ was 12 points from his average. What possible point totals could Jordan have scored? Write and solve an absolute value equation to answer this question. And I don't necessarily care about the equation. I want you to answer the question. Okay? So he averaged 37 points a game. It says suppose in one game he was 12 points from his average. So what are the possible points he could have scored? Okay? And that should be written as a compound inequality using and. All right? So you think about it for a second. All right? So the fewest was 25, the most was 49. So we'll say P would have been greater than or equal to 25 and less than or equal to 49, right? Okay, so let's think about what that inequality would have looked like. All right? So we have two numbers that we really care about, correct? 37 and 12. All right? So if we write an absolute, so if we go backwards for a moment, okay? How did I get those two numbers? What did we do? Okay, we subtracted 12 and added 12, right? Okay. So would my inequality look like this? Or would my inequality look like this? which one would be the correct inequality? The one on your left hand or the one on your right? Okay, raise that hand for which one you think it is. Okay, all right, so we could check it too, right? We could say, all right, x minus 12 is less than 37, or x minus 12 is greater than or equal to 37. So if I add 12, oops, negative 37. Okay, so if I add 12 here, I get x is less than or equal to 49. Okay, that's good. But if I add 12 here, I get x is greater than or equal to negative 25. Oh, wait a minute. It wasn't the one on the left, was it? Okay, how about you? All of you thought it was the one on the left, didn't you? Okay. Keegan, you didn't? You didn't answer, did you? Oh, you thought it was one on the left. Okay. All right, it's the one on the right. Okay. So the middle number for the inequality is actually inside the absolute value. The difference is outside the inequality. All right. So this one did not work. My absolute value inequality would be that one there. Okay? Good. All right. Give you just a little something extra to think about with that one. Pause. In your